Good evening. I'd like to tell you a very short story. It's a story about truth and skepticism. It's a story about probability in the real world. It's a story about the probability of life and death. 10 years ago, this past October, I got a call in my fourth period class. It was from my wife. It was not good. Her biopsy for breast cancer had come back positive. This started a set of months of great emotional turmoil. We talked to one doctor who said that chemotherapy was absolutely necessary, the next one who said absolutely not, and the third said, well, I would probably be your choice. She took one important test that came back positive. The very same test came back negative the second time and indecisive the third time. We had a period of time during which we slept with uncertainty. We became our own medical advocates. I'd like to cut that short and say with great relief that after the operations and the medical procedures, she is fine and in the audience today. By the way, this is a picture from this past April at the Emmy Award ceremony. I'd like to talk to you about probability. I'd like to talk to you about the results of that first test. Imagine for a moment that you're feeling bad, you go in for a test, you figure that there might be a problem, and then you get a call. The test has come back positive. And it's come back positive for a rare disease. Let's say some kind of cancer, let's say malaria, and your skepticism, on the other hand, takes you to question the doctor. How good is the test? Of course, you want to ask. And the doctor says, the test, unfortunately, is 95% accurate. You have a 95% probability of having the disease, says the doctor. Is this prognosis accurate? Because we're talking about death. We're talking about a period of time during which you are closing up shop. You are saying goodbye to your friends. You are going into a tunnel. Is this necessary? Well, skepticism takes you back to the doctor and you ask, how is the test actually performed? What does 95% accuracy actually mean? And he says the following. If you take, he says, 100 people who have the disease, then the test given to those 100 people, it will tell 95 of them that they have the disease, which is correct. Unfortunately, it will tell 5 of them that they don't. If you took 100 people who don't have the disease, the same thing happens. 95 of them will be given a clean bill of health, and unfortunately, 5 of them will be told that they have the disease. These are the false positives. And so you think, this is terrible. You sit for a while and you think. And one of the things that you think about is you may not know medicine, but you know probability. But you know probability. This is what the doctor has said. He has said that if you have the disease, then the chance that you're going to have a positive test is 95%. But it occurs to you immediately, this is not what you want to know. This is exactly the opposite if you take a look at conditional probability. You don't want to know that if you have the disease, you're going to come back positive. What you want to know is if you have a positive test, do you have the disease? These are not the same. And so, what you can say is, if you have had a decent course in real-world probability, you can get from what you know to what you don't. Let's say that the disease occurring in the general population, 1 in 1,000 people has it. That's called the a priori probability. This is what you know. We have the probability of the disease is 1 in 1,000. If you have the disease, this is what the doctor says, if you have the disease, then the probability of a positive test is 95%. And if you don't have the disease, the probability of a negative test, negative result, is also 95%. This is what the doctor means by 95% accuracy. But let's see what we can do. If this were a different audience, I would say this is a trigger point for algebra. Trigger warning. Bayes told us, Reverend Thomas Bayes from 1763, told us how to get from one to the other. And this is Bayes' theorem. And it turns out that we have all the information in order to evaluate, to use Bayes' theorem to get what we really want. And so plugging in the numbers, we have 95% times the probability of actually having the disease in the general population, and we do the calculation, and the calculation comes out as 1 in 51, which is different a little bit than this is death and this is life. Is that period of time during which you're saying goodbye to your friends necessary? But you don't have to do this algebra, although I teach it. You can get an immediate and intuitive notion. But before I go through that, Bayes' theorem is there just exactly for these kinds of situations. Bayes' theorem allows us to update our belief when new information comes in. We started with the information of 1 in 1,000, but we got a positive result, and so it's natural that our likelihood of having the disease actually rises. And it did, from 1 in 1,000 to 1 in 51. It's a factor of 20. It's a big deal, but it is not 95%. Let's get a more intuitive notion of why this is very easy to calculate, and intuitively why it's about 1 in 50. Well, let's suppose we take 1,000 people. One of them has the disease. That person, let's give the 1,000 people the test. That one person very likely to be positive on that test. But then, out of 1,000 people, 5% of them will get the wrong results from the test. The test will come back positive for 5%, and that's 50. And now, you're in this pool. What you know is you have a positive test. You're in a pool of 51 people. What's your chance of having the disease? 1 in 51. It really doesn't take fancy algebra to know that, although that helps. Okay. Now, you might object and you might say, well, you know, any doctor worth his or her salt will tell you this is just the first test. There'll be other tests that you're going to have to take, but there is that time between the first test and the second test. And that's the time you're closing up shop. You can object and say, doctors don't make these kinds of mistakes. I mean, they give prognoses all the time. They should know probability. This is their trade. Here's an article from the New England Journal of Medicine, the premier medical journal in the United States. This is from quite a number of years ago. There's a little informal survey. I don't want you to read it. I just want to say that these people, this is very informal, these people asked 40 doctors and 20 fourth-year medical students who were working at Harvard University teaching hospitals just exactly the scenario that I outlined a moment ago. 1 in 1,000 chance of one of their patients having a particular virulent disease, and the only indication that they have is that a test came back positive, and that test has a 5% false positive rate. And they asked these doctors and medical students, what will you tell this patient? What chance would you give this patient for having the disease? The answer is 27 out of 60 said 95%. And if you took the average of all of their estimates, it would come to 56%, which is 30 times the correct answer. Now, we learned a great deal about skepticism when we were fighting this disease, when my wife was fighting this disease. Okay? And from that experience, 10 years ago, and from a great deal of thinking, I was lucky enough 4 years ago at Stuyvesant High School to be able to create a course of my own, to teach thinking in the real world. The course is called Human Reasoning, and in the first semester, I cover critical thinking and topics like logical biases and fallacies, logical paradoxes, mental arithmetic, estimation, guessing, and more current topics like how to recognize fake news when you find it in the back alley. And finally, in the second semester, since this is a math course and I have to deal with the math department, I deal with risk and a whole variety of different ways of using mathematics to deal with the real world. When I learned probability, I had problems like how many socks do you have to take out of a drawer at night to ensure that you have a pair that match? Or what is the probability that when you take 2 red balls and 1 white ball out of a bag, there will be a certain particular combination? This doesn't help me. It doesn't help me in the real world. I want to be able to apply the mathematics to everyday life. And that's what I want to teach. Skepticism and real-world probability, that's what I'd like to teach my students. Thank you very much.